Okay, these notes are basically an introduction to polyatomic ions. A polyatomic ion is a group of covalently bonded atoms that act as a single ion. Now, when we make ionic compounds, the majority of the ionic compounds found around the world usually are made up with a metal plus a polyatomic ion. So I wanted to do a little set of notes here so that you could see what actually a polyatomic ion is. So hopefully when we get to naming them and writing formulas with them, it won't be so confusing. So let's look at phosphate. That's one polyatomic ion. Now phosphate, let's look at the name. Phospha with a pH in it. Reminds you a little bit of phosphorus, right? Well, guess what? That's the center atom. So phosphate is, whoops, actually, let me go ahead and put my pencil back on, is a P with 4 oxygens covalently attached to it. And this whole thing has a -3 charge. So when we write this, we write it as PO4 3 negative. Okay? So that's one of them. Now let's look at the next one. Let's look at another one. This one is nitrate. Now, nitrate, because it has the nite in it, it probably has nitrogen, right? It does. It's nitrogen with 3 oxygens attached to it. And this whole thing has a -1 charge or a negative charge. Remember, we never write the 1 down because it's assumed it's a 1. If you write a charge down, it's assumed there's at least 1. So we write this as NO3 to the minus sign. Now, don't forget, this is not NO with a -3 charge. Okay? This is the N with 3 zeros attached to, or 3 oxygens attached to it, and then the charge is a -1. That can get a little confusing when you're writing stuff. So just remember, there's a subscript and a superscript. The superscript is the charge for the whole thing, whereas and the 3 means there's 3 oxygens attached to that 1 nitrogen. Okay, so let's go to the next slide. Okay, so let's talk about some common polyatomic ions. I've got the names already typed out, so you'll still have to write the name, and I'm going to write the formulas down. Now, here's the thing. If you don't write this down, you will never have them. You're not going to be given a polyatomic ion chart, okay? When we take the test on all of this, it's open notes, which means you're going to need your notes out. So make sure you have this set up in a chart or somewhere where you can easily read it, because you're going to need to be looking back at this quite a bit, okay? So our first one is ammonium. Now, ammonium is NH4 with a plus charge. So it's 4 H's hooked up to a nitrogen, and the whole thing has a plus charge. So it kind of looks like, and no, you don't have to write this, but I just wanted to show you once again what it looks like. And this whole thing has a plus charge, okay? That's what ammonium is. Okay, so now the rest of them, I'm not going to draw pictures. I'm just going to put the formula down. Acetate, C2H3O2 with a minus sign. And you guys should be familiar with the word acetate. If you've ever drank anything German, it's made with vinegar. Well, vinegar is 3% acetic acid. And all acetic acid is the acetate ion with a hydrogen attached to it. So you've heard of it before. Okay, cyanide. You guys have heard of cyanide. It's a dangerous poison. Actually, it's hydrogen cyanide or sodium cyanide. But the cyanide ion is the poisonous part that gets in your system, gets in your blood, and that's what will kill you. Okay, hydroxide. I know you guys have heard of hydroxides. It's OH minus, sodium hydroxide, potassium hydroxide, basically drain cleaner. Okay, let me move this up a little bit. And now we have something called thiocyanate. And that's the cyanide ion with an S. Whenever you see the word, the prefix thio, that means an S is attached to it. So thiocyanate. Okay, so let's go to the next one. Okay, and now we have the chlorite group. So we have hypochlorite, chlorite, chlorate, and perchlorate. Now these four, there's only one difference between them. Each time you write it, you're adding a zero, or an oxygen actually. So like hypochlorite is Cl, which means chlorine. So that's a little L, capital O with a hypochlorite, and you know the name is chlorine, so it's Cl, has a Cl with one oxygen. Chlorite is Cl with two oxygens. Chlorate is Cl with three oxygens, and perchlorate is Cl with four oxygens. Now they all have a -1 charge, so they're all minuses. Pretty cool, huh? Okay, now let's do the next bunch. Now these two, nitrite and nitrate. Obviously they have the N. Now, if you remember from the first slide, I gave you nitrate. Well, nitrite is similar. It's just nitrate with one less oxygen. So if you look above with the chlorite and the chlorate, the ite has one less oxygen than the ate. Okay? Okay, permanganate is the next one. Permanganate is Mn, so it has manganese in it, O4 with a minus sign. Now, hydrogen carbonate is HCO3 minus, but another word for it is bicarbonate. Long time ago, bicarbonate. It's actually a buffer. So when people used to get stomach upset, they used to take sodium bicarbonate. In fact, that's what Tums, I guess Tums is it? One of them. But one of the stomach medicines is actually sodium bicarbonate. So it's basically the HCO3 minus with a sodium attached to it. And we're going to make that compound at one point. So you'll learn how to name it. So when you see NaHCO3, it's actually the chemistry name for it is sodium hydrogen carbonate, but the old name for it would be sodium bicarbonate. Okay, and then we have hydrogen sulfate. And that also has a -1 charge, and that's called bisulfate. And there are more of these, and if we ever use them, I'll give you the names for them. But these are the two I tend to use a lot, so that's why I'm giving them to you. Okay, now let's go to the carbonate. All right, now those were all the -1s. If you notice, every single one of those just had a negative charge. Carbonate is the first one we're encountering that has a -2 charge. Oops, hang on. And we write that. Now you can write that as a -2 or a 2-. Some people like to write, and you'll see me write it both ways, as a -2 or a 2-. Either way is acceptable, as long as you're showing the charge, which is the number and the sign of it. Sulfate is SO4, 2-. Sulfite, now if you remember from nitrate and nitrite, nitrite had one less oxygen. Well, guess what? Sulfite has one less oxygen. So the ite always has one less oxygen than the ate. Okay, now we have thiosulfate. So thiosulfate is sulfate with an extra S. This probably should be thiosulfite because it's really sulfite with the extra S. But what happened was one of the oxygens got taken off and replaced with the S. That's why it's thiosulfate, because it was originally sulfate. That has a -2 charge also. Okay, now we have oxalate, C2O4. Now peroxide, and I know everybody here has heard of peroxide. You got hydrogen peroxide. If you get a cut, you put hydrogen peroxide in it. Well, that's H2O2. So O2 is the peroxide ion, and it has a -2 charge. So really, peroxide is an oxygen double bonded with another oxygen. Actually, single bonded, sorry. It's not double bonded. But it's really just an oxygen bonded to an oxygen, and it has a -2 charge on it. So it's not two oxygens kind of in a compound. It's two oxygens covalently bonded together. Okay. Okay, let's do a couple more. We got chromate, which is made from the chromium ion, CrO4. Now dichromate. Di is a prefix that usually means two, and in this case it does. It's two chromiums. It's almost the chromate ion doubled, okay? If it was actually fully doubled, we'd have to divide it by half and get it back down to CrO4. But this way we have Cr2O7, okay? So that's the difference between the two. Okay, that's the last of our -2 ones. Now let's go to the -3 ones. Phosphate you saw before was PO4 with a 3-. Now phosphite, just like all the other ites and ates, ite has one less than 8. So it's PO3, 3-. Whoops, that is not a very good 3, is it? So let's make that a better 3. Okay, now arsenate is made with the arsenide ion. I can't even talk today. Arsenide ion with 4 oxygens attached to it. And that makes it a -3 also. Okay, so that's it for the polyatomic ions. Please make sure that you've written them out in a way that you can find them again. If you didn't, I would rewrite them. In fact, I would put them all on a separate page, just its own, with all the common polyatomic ions written. If there's ever a polyatomic ion that I start using that you don't have on your list, I'll have you put it on this list. But you are going to need to look at this list unless you want to memorize it, and I kind of doubt you do, because I wouldn't. Just make sure you have it handy. Okay, and that's it for today. The next set of notes will be writing formulas with polyatomic ions. And that we'll be using these. So I'll teach you how to use them then. Okay, bye.